Hello, and welcome to the presentation of Ryerson Hill Quarry, Maine, Pegmatite Contamination and Titanium Dioxides. I'm Lloyd W. Alexander, and my co-authors are Alexander U. Falster and William B. Simmons. Ryerson Hill Quarry is located in Paris, Maine, and is a complex pegmatite. It's about 50 meters long from pit edge to pit edge and 12 meters wide. Ryerson Hill Quarry has been mined sporadically over the years. A geological survey was done in 1911. Dick Dion had the mineral rights in mind from 2000 to 2003. Zoltan Matulski, 2010 to the present, has been mining, and I have been studying since 2018 to present. Here is a list of mineral groups and minerals found at Ryerson Hill Quarry. Additional new listings are expected as the analysis continues. On this map, we can see Ryerson's location in comparison to many of the local mines. But more importantly, let's look at the Songo Pluton and Sebago Pluton. Ryerson is nowhere near these. Last year, with our unusual rutile find, we didn't know where or why that happened without the plutons to aid. Add in now that we have anatase, ilmenite, and titanite, and the mystery grows as to why Ryerson. In this image, we can see known contact points. They're highlighted with the blue lines. If you notice on the 2017 to 2022, there's a convergence and overlap of many contact points. This is an important observation that was made in the study area. The observation of all of these contact points in the study area was a big clue into what might have happened at Ryerson Hill. Metasomatism is a geological process that involves the chemical alteration of rocks by fluids. Pegmatite contamination and pegmatite assimilation are two types. Pegmatite contamination occurs when a fluid-rich pegmatite intrusion comes into contact with a pre-existing rock, causing the fluids to interact with the surrounding rock and alter its chemical composition. The fluids from the pegmatite can introduce new minerals and elements into the host rock, leading to the formation of new mineral assemblages or changes in the existing ones. Pegmatite assimilation occurs when the pegmatite intrusion itself undergoes chemical changes as a result of its interaction with the surrounding rock. The fluid-rich pegmatite can dissolve and incorporate elements and minerals from the host rock, leading to the changes in the pegmatite's mineralogy and chemistry. You may be thinking metasomatism must happen all the time, and it does when there is an intrusive magma and it comes into contact with the host rock. This does occur. Why is Ryerson different? Ryerson, as we showed before, has many contact points, and they overlap, and they're in a very tight area. What we believe is that this allowed the magma to intrude further, warm the host rock more, have the fluids mix more, and that resulted in the titanium being released from the host rock. On this slide, we see the 2022 study area. If you look at the gold line, that was the unusual find of rutile from last year. So I decided to start from the black line, which is a garnet line, and head towards the rutile line. The green area is where titanium dioxides have been found thus far. The red is the moly pocket, and if you look at the blue contacts, they converge right there. V1 and V2 are smaller bugs that did produce some titanium oxides, and they are again on a contact line. If you look at the brown line, I've removed about 8 centimeters or so of schist pegmatite from the top that has been pretty bare of minerals. We're hoping to go deeper from the back, from the black line all the way up to the rutile line and possibly wider to see exactly where the titanium oxides stop. So hopefully in 2023, we will get this done. These three crystals were a very exciting find. Beautiful anatase found in the Molly pocket. The largest in the middle is 10.19 millimeters high. Its width is 5.91 millimeters and its thickness is 5.07 millimeters. This anatase is the largest in Maine, New England, the Northeast, and comparable to the largest in North America. This is based on a review of 364 photos on MinDat as of 1/23/2023 from Canada, Mexico, and the United States. Other notable anatases are from Arkansas, California, Texas, and Quebec. Here are two more images from the Molly pocket. Both these pieces are just beautiful. On the left, we have an anatase. You can see the blueness in the crystal attached to an L-bait Schorl series rod that you can actually see is pretty clear itself. Just a beautiful piece. On the right, we have a long L-bait Schorl series rod that somehow stayed intact. It's beyond me how something this long cannot get broken in the process of collection. It's 37.96 millimeters long and 2.17 millimeters in thickness. Just amazing pieces. One of the fun things about the Molly pocket was it was full of micro-sized pocket barrel and Schorl and L-bait rods, various lengths, various diameters. These ones are uncleaned, but when they clean up, they're crystal clear. Also in the Molly pocket, there are a lot of interesting combinations of crystals. On the left, we can see Schorl with fibrous rods sticking up. On the right, we see a quartz crystal with an L-bait Schorl rod sticking out of it. On this slide, we have two rutile crystals, the left image and the middle image, and on the right, we have an anatase cluster. Here on the left, we have ilmenite. In the middle, we have various pieces of ilmenite transitioning to rutile and the variety sagenite. On the right, we have sagenite sitting on top of schermicite. In this image, we see the light green, which is epidote, and the darker green, which is schermicite, sitting on top of albite. This was a late stage growth. On this slide, we have anatase and rutile from the Ryerson Hill Quarry with their SEM analysis. On the left is anatase, on the right is the rutile. If we look, they match up very well. This was typically the case at Ryerson Hill with SEM analysis of several anatase and rutile. On this slide, we have brookite. On the left is Magnet Cove, Arkansas. On the right is brookite that was found at Ryerson Hill Quarry. Please take note of how similar these are. Let's take a look at this EDS overlay. In red is brookite found at Magnet Cove. In green is brookite found at Ryerson Hill. Look how exactly they match up, peak for peak. Now, let's take a look at anatase from Ryerson Hill and brookite from Magnet Cove and Ryerson Hill. If you look at the 5, you can see that the titanium is there on both. And a little bit further out, the iron is there on both. What is different is that the Magnet Cove and Ryerson Hill brookite has vanadium and the anatase from Ryerson Hill does not. This is very important. Now let's take another look at this EDS overlay. Remember, Magnet Cove is in red and the brookite from Ryerson Hill is in green. Look how well they match up. And they both have vanadium. Vanadium has never been found at Ryerson Hill, either in the study area or outside of the study area. And it is actually a signature of the Magnet Cove brookite. Thus, the only conclusion is that the Ryerson Hill brookite was planted. The finding of planted brookite at Ryerson Hill was very disappointing to me. In the end, though, it shows why research is important. To understand pegmatite and its relation to the surrounding stratigraphic layers, to understand the relationship of rocks in the rock cycle, to find and ID minerals, which helps gives a better picture of the composition and the conditions of creation, to ensure the authenticity of minerals and their locations, to continue to evolve our understanding of the world that we live in, to find important new minerals and deposits that help the world. A study done correctly addresses all of this from the start. Ryerson Hill study has been done correctly right from the start, and that's why we were able to catch the planted brookite so easily. The legitimacy of these three large annotates found in the Molly Pocket remains unquestioned. I would like to thank my co-authors, the MP² Research Group, Maine Mineral and Gem Museum, and the Matulski family for all of their support. Now I'd like to hand it over to Al Falster to talk about the planted brookite, and then I'll be back with Al for a Q&A.
Well, you may remember in the 90s, we gave a talk at Rochester one time about the titanium oxide species from Magnet Cove. Magnet Cove was one of our favorite locations from the University of New Orleans for students to collect minerals. And we analyzed, of course, a lot of these titanium oxide species, including the ones from Moses Hill. And they always had about 0.5% vanadium pentoxide in it. It so turns out that the country rock up there, some of the metasediments are vanadium rich from deep sea sediments. And we had some contamination when these quartz veins that carried the brookite into this country rock got contaminated, and some vanadium was incorporated into the brookites. Morphologically, the Moses Hill brookite is also very, very distinctive. And in a pocket, in a pegmatite, to find even two polymorphs of titanium oxide is rather interesting. To find three would mean we would have to be right at the triple point where they can coexist. Two of them is much easier to explain. Now, another thing was that a very interesting thing must have happened in this pocket because these crystals had been cleaned. So the pocket had apparently some iron out available that could clean the iron oxide off. The only thing that it didn't have in the pocket was a perky box to mount these things up. So we don't know what happened. We don't know who did it, but the brookites did not belong there. They were added to that, or maybe they migrated on the little feet in there. That's just, maybe they have feet when they don't watch. But it shows us the power of analyzing things and checking things to confirm what we have is really true. In a way, it's disappointing that some people would add some things in there. It's already complicated and time-consuming enough to go with the real stuff out of a location. We don't need interference when somebody, some unknown person, we have no idea who it was, tries to complicate things for whatever reason. This is not kosher. And it's disheartening, especially for a young person like Lloyd, who is trying to get his feet on the ground. He has since joined up and is studying at the University of New Hampshire to get a degree. And that was maybe partially enhanced by this experience because he wanted to be able to stand on his findings and have a real voice in this field. So for that, I highly respect him, what he has done. And as bad an experience as it was for us, something good came out of it, that now he, instead of being just a collector, he will eventually become a colleague. And he's well on his way to that.